Hi, Math 2. So previously we've learned how to simplify radicals, but it was with numbers inside, just numbers. Now we're going to simplify radicals with numbers and variables inside. So if we look at the first example here. First, let's take care of the 32 because we know how to do that, right? We can break down the 32 into 16 times 2. Now, why did I think to do that? Well, remember, we've got a square root here, and you're going to have to go to your perfect square. So if you go to that perfect squares chart you have, you're going to start trying to figure out which one of those are factors of 32. And remember, you want to start with the highest number you can. So if you're starting at 32, you're going to go 32 divided by 25, 32 divided by 16, and you'll find out that 32 divided by 16 works, and you're going to do 16 times 2. All right. Then we've got our x's here. So one thing I want to point out, remember how when we did the numbers, they had to be squares in order to leave, okay? This square root has like an implied 2 there. We don't write the 2. It's kind of like, you know, when you have an x, you don't write 1x. I'm sorry, you don't write 1x and you don't write x to the first. They're like implied numbers there, right? That's the same thing when you do a square root. It's an implied 2 that you don't write. So basically, the way you want to think about this is that in order to leave the radical, you need to have 2 of something, okay? And so it's kind of like a buddy system. It needs 2 to leave, and when they leave, they become 1. All right, so let's go ahead and see if we could kind of break these guys down into groups of 2. Well, the x to the 4th can become x squared and x squared. The y to the 7th can become y squared, y squared, y squared, and y. And then the z to the 9th can become z squared, z squared, z squared, there's a lot here, z squared, and z. Notice how all of these add up, right? Because we had 7 y's, we got 2, 4, 6, 7. Z's, we got 9, 2, 4, 6, 8, 9. All right. So now all of these squared guys can leave. Now you're probably wondering, oh God, there's got to be a better way. Yes, we're going to talk about a better way to do this, but I want you guys to visually see what's going on here. So all the guys that are squares are able to leave. So we got a 4 that can leave. We've got 2 x's that can leave. 1, 2, 3. We got 3 y's. And we've got 4 z's. All right, and then left inside, we've got a 2, a y, and a z. So then we would write our answer. Oh man, I'm really running out of space here, huh? We would write our answer as 4x squared, y to the 3rd, z to the 4th, root 2 yz. And that would be our answer there. So you're probably thinking like, oh my gosh, this is kind of, you know, this is a lot. There are kind of easier ways to do this in your head, and we'll kind of talk about that. All right. So if we look at example number 2, let's go ahead. All right, let's go ahead and try another one. So for example number 2, first let's go ahead and break down 192. So again, we've got a square root. So we're trying to pull things out in pairs, right? We got to find a perfect square is essentially what we're looking for here. So if we go through, we do our division, we should figure out that we could break 192 up into 81 and 2. All right. So we could rewrite that as 81 times 2. We still got our x third, y to the 8th, and z. So 81 is the same as 9 squared, right? We've got our times 2, and then of course we could rewrite our x as x squared times x. Our y could be written as y squared, y squared, y squared, y squared, and our z is there. So again, we can take everything out that is squared, so we could take this 9 out, and the square just becomes regular, so we just get a 9. Keep in mind the 2 needs to stay on the inside. I can bring the x out, this x squared out. Then this x needs to stay on the inside. Then I can bring out 4 y's. So I'm going to go y to the 4th. And then we've got Z on the inside. He doesn't have any buddies, so he's stuck in there. So this would be our answer. All right, so for example number 3, we've got a cube root. So remember that when we do a cube root, we have to use our perfect cubes. So first, let's go ahead and break down 81. We can break this down into 27 and 3. Why did I pick this? Well, 27 is a perfect cube, and it's going to be the largest perfect cube that goes into 81. Then we're going to go ahead, let's rewrite this cube root. And then 27 is 3 cubed times 3 times, and then we can say x to the third times x squared. And then we can say y to the third, y to the third, and y to the third. Those are going to add up to our 9. And then our z squared, we can't really do much with. So let's go ahead. We can move this guy out. We can move this guy out. So we've got an x on the outside. We can move 3 y's out. So we're going to do y to the third. And left on the inside, we've got a 3, an x squared, and a z squared. So we're going to do our cube root, 3, x squared, z squared. And that would be our answer for that one. All right, next one. So again, we're going to go ahead and try and use our perfect cubes to try and break this down. All right. So let's see, 54, we could break that down. Yes, we could do 27, oops, again, and 2. All right, that would give us 54. So again, we're going to rewrite this. 3 cubed times 2 times, and then the x to the 12th, we can do x to the third, x to the third, x to the third, and x to the third, y to the third times y, z to the third, z to the third, and z. So notice, how am I doing this? All of these are adding up. 3, 6, 9, 12. That gives me my 12 there. 3 and 1 give me my 4. 3, 3, 1 give me my 7. All right, so that is how I got that. So now we're going to go ahead and see what we can pull out. So we can pull a 3 out. We can pull 4 x's out. We can pull a y out. And we can pull 2 z's out. So I guess I should mark down what I took out there. So then we are going to be left with 2 y, z. All right. And that would be your answer there. All right. So now let's go ahead. Let's see if you can do these. So go ahead and give this one a shot here. Now, what I'm going to do is I'm actually going to kind of explain this in a slightly different way than how I explained it before. You'll get the same answer, so you can still use that first method I taught you, but hopefully this next method will be a little bit quicker. It's kind of how I do it in my head, all right? So, of course, we still have to break this down. I'm going to break this down into 125 and 2, all right? So we've got cube root, and we're going to have 5 cubed times 2. Now, I'm just going to rewrite it like this. Oh, whoops. The way that it was. And explain to you how I do this in my head. So, of course, I got to take my 5 out, all right? And then I've got my 2 left in there for sure. So now I got to look at my x. So I always think of the fact that like I take them out in groups of 3. So if I look at 4, if I do 4 divided by 3, well, I get to take 1 out, and then my remainder is 1. So I'm going to have 1x left in there. Then I've got my 8. 8 divided by 3, I am going to get 2. So I get y squared. And then my remainder is 2. So I'm going to have 2 left over in there. And then for z, I'm going to do 3 divided by 3. I get 1, so I can take 1 out. And this would be my answer there. If that method confuses you, you don't have to use the remainder method. You can do that thing where you write out all of your, you can write it all out step by step. But I figured I would kind of explain the way that I do it in my head for those of you who want to do this a little bit more quickly. All right. Let's go ahead and try this next one. So we've got root 162, x to the 5th, y to the 6th, z. So go ahead and give it a shot. I would break this down into 81 times 2. So we're going to have 9 squared times 2. And then, of course, we've got our x squared y squared, and z. So I'm again going to explain it to you how I do it in my head. Of course, I can pull my 9 out, and my 2 is stuck in there. And then I've got, ooh, this is a 5. I don't know why I put 2's there. Sorry. It was a 5 and a 6. So for my x, I'm going to do 5 divided by 2. That means I can take 2 out, and my remainder is going to be 1. For y, I've got 6 divided by 2. That gives me 3, so I'm going to have y to the third. I don't have any remainder. And then z, I can't take any out because I don't even have 3 to begin with. I only have 1, so my z's got to stay in there. So this would be my answer there. Next one. Again, go ahead and try and give it a shot. All right. When I do this one, I'm going to go ahead and break down 128 into 64 times 2. So we've got 8 squared times 2, x, y to the third, z to the fourth. So I can take my 8 out. My 2 is stuck in there. My x can't leave. He doesn't even have 3. My y, I've got 3 divided by 2, so that means I can take 1 out, and I've got 1 left in there. Z, I'm going to do my 4 divided by 2. That gives me 2. So this would be my final answer there. All right, last one. So we've got cube root of 108, x to the 10th, y to the 6th, z to the 5th. All right, so let's give it a shot here. We can do 27 times 4. That'd be a great way to break that down. So we've got cube root of 3 cubed times 4, and then x to the 10, y to the 6, z to the 5th. So let's go ahead and break it apart. We're going to take our 3 out. Our 4 needs to stay on the inside. We're going to do 10 divided by 3. So that tells us we can take out 3 of them. And we've got 1 remainder, so 1's going to stay in there. I'm going to do 6 divided by 3. That's going to give us 2, so we got y squared on the outside, no remainder, so none left on the inside. And then z, we've got 5 divided by 3, which is going to give us 1 and 2 remainder. So we've got 2 on the inside. So that is how I would do that. Again, feel free to use that first method I taught you where you write it all out. I will be honest, this method is a lot quicker, but if you don't feel comfortable with it and you're struggling with it, don't worry about it.